Hello and welcome students. Today's topic of deliberation is about fruit jams. The main objectives cover the general introduction of fruit jams, to acquaint students about different unit operations required for jam preparation, to acquaint students about quality control measures for jam. Fruits have been a part of man's food since times immemorial. Among the preserved fruits, jams constitute important product and effort means of utilizing a large amount of sound culled fruits unsuitable for other purposes. It's an older method than canning and freezing. Historically, jams may have been originated as an early effort to preserve fruits for consumption in the off-season. The definition of fruit jam issued by FDA in 1963 is: fruit jam is a product made by cooking to suitable consistency, properly prepared fresh fruit, cold stored fruits, canned fruit, or a mixture of two or all of those with sugar or with sugar and dextrose with or without water. In its preparation, not less than 45 lb of fruits be used for each 55 lb of sugar and dextrose. Jam is prepared by boiling the fruit pulp with sufficient quantity of sugar to a reasonably thick consistency, firm enough to hold fruit tissues in position. It should contain not less than 68.5% soluble solids as determined by a refractometer. Jam may be made from a single fruit like apple, strawberry, banana, pineapple, etc., or from a combination of two or more fruits, can often be made to pronounced flavor, color and acidity. The preparation of jam requires several unit operations, that is, selection of fruit, preparation of fruit, addition of sugar, addition of acid, mixing, cooking, filling, closing, cooling and storage. Now coming to the preparation of jam. Fresh fruits generally give the best jams. As pectin is the main ingredient in the fruit that gives a set to the jam, it's preferable to use a slightly underripe fruit that's rich in pectin along with the ripe fruit to secure the desirable gelling effect of the jam. Apple, pear, sapota, apricot, locust, peach, guava, papaya, coronda, plum, strawberry, mango, tomato, grapes, muskmelon, etc. have been used for preparation of jams. First step is the preparation of fruit pulp. A jam is more or less concentrated fruit possessing a fairly thick consistency. A jam manufacturer can choose a fruit from among the following 5 categories. First is fresh fruit. Second, frozen, chilled or cold stored fruit. Third is fruit or fruit pulp preserved by heat. Fourth is sulphited fruit or fruit pulp, that is, fruit preserved with sulfur dioxide. And fifth is dried dehydrated fruits. Now, fresh fruit pulp. Peach, pear, apples, apricot, plum, prunes are washed with acidified water, that is 0.1% hydrochloric acid, to remove dust and dirt after removing leaves, stalks and other undesirable portions from the fruit. Strawberries are crushed between rollers. Raspberries are steamed, crushed and passed through sieves to remove the hard core. Fruits like plums, apricots and peach are heated with about 10% water until they become soft and are passed through a wide mesh sieve of the pulper, which is used with rubber to separate the stone and skin. Other fruits are suitably treated to get desirable pulp for making jam. Next is frozen fruit pulp. Frozen fruits are allowed to defrost at ambient temperature before preparation of pulp on the analogy of fresh fruits. Jams prepared from frozen fruits are as good as prepared from fresh fruits, but in India, jam is seldom prepared from frozen or cold stored fruits due to some economic reasons. Next is pulp preserved by heat treatment. Pulps preserved by heat treatment are rarely used for jam making. Rather, fruit pulps preserved by heat are often used for preparation of ready-to-serve beverages in which residual chemical preservatives are not allowed legally. Next is pulps that are preserved by sulfur dioxide. For preserving fruit pulps in bulk during peak production season, sulfur dioxide is used universally in the form of potassium metabisulfate, sodium sulfite or calcium sulfite. Most of the pulps are preserved in 1000 to 1500 ppm sulfur dioxide. Next includes pulps from dried fruits. Pulps can be prepared from the dried fruit like apple and pear rings, dried apricots and prunes after soaking them in appropriate quantity of water, boiling and then filtering through the coarse sieves. Next step includes addition of sugar. Generally, canned sugar, that is sucrose of good quality, is used in the preparation of jams. The proportion of sugar to fruit varies with the type and variety of fruit, its stage of ripeness and acidity. Sweet fruits require less sugar than tart fruits, although fruit pulp and sugar is in the ratio of 1:1 and it is generally acceptable. This is usually a suitable ratio for berries, currants, plums, apricots, pineapple and other tart fruits. Next step is addition of acid. Citric, malic or tartaric acids are present naturally in different fruits. These acids are also added to supplement the acidity of the fruits deficient in natural acids during jam making. Addition of acid becomes necessary as adequate proportion of sugar, pectin, acid is required to give good set to the jam. Now processing techniques. Number first is traditional concentration. The traditional process used for boiling jam is the open kettle batch boiling technique. Steam jacketed, preferably stainless steel or aluminium kettles are commonly used commercially to prepare the jam. The kettles are steam heated at 60 to 80 psi pressure. The fruit pulp and sugar are weighed separately before mixing in the kettle, which is then boiled rapidly to concentrate to the end point. The boiling process, in addition to excess water removal, also partially inverts the sugar, develops the flavor and texture and destroys microorganisms like yeast and mold. Next technique is vacuum concentration. Some modern fruit processing units use vacuum pans with increased output for boiling, which work under reduced pressure at a temperature of about 65 to 76 degrees centigrade. The vacuum boiling has an advantage of minimizing the undesirable changes in flavor, color and nutrients. Volatile esters are collected by process of recovery and put back in the jam. Next technique is plate evaporation process. In a typical plate evaporation plant, first stage is the mixing together of ingredients which would normally include fruit, pulp, sugar, pectin and possibly corn syrup. The ingredients may be weighed into the batch premix vessel. The premix then goes through a paraflow plate heat exchanger where it is heated by condensate and steam. If sulfited fruit pulp is used, the hot mix enters a desulfiting column. The concentrated jam and vapors are discharged through a large rectangular part to a snail separator where jam is separated from the vapor. The jam is extracted by a rotary pump. The product then passes through scraped surface cooler before passing to bottle, storage and to filling. Next step is addition of pectin. Fruits possess gel forming characteristic due to the presence of a substance that is known as pectin. Originally, jam or jelly production relied on the native pectin of fruits for gel formation. In spite of the current availability of other gelling agents, pectin remains the universal choice for jam and jellies because of its natural occurrence as fruit ingredient and the characteristic consistency imparted by it to the gel. In the fruit pulp preserved with sulfur dioxide, pectin is degraded, resulting in poor jam setting. Pectin deficiency is remedied by the addition of commercial pectin at the rate of about 0.1 to 0.2% depending on the pectin grade. Next step includes addition of color. To give attractive appearance to the jam, only the permitted colors such as carmosine for mixed fruit jam should be added at the end of the preparation. Color should be dissolved in minimum quantity of water and poured dropwise over the prepared jam with constant stirring. Now, addition of essence. When jam is prepared from fresh fruit, ordinarily no flavor is required. But when preserved pulps are used for jam making, commercially available fruit essences are added at the end of preparation and mixed well in the jam formulation. Next step is finishing point. Concentration of jam is finished at an optimum point, avoiding overcooking which leads to economic losses because of less yield. The finishing or end point of jam concentration can be determined by any of the following methods. Number first method is drop test. This test is the simplest way to determine the finishing point of the jam, commonly used by housewives where no other facilities are available. In this method, a little quantity of jam is taken from the boiling pan in a teaspoon and allowed to air cool before putting a drop of it in a glass filled with water. If the drop of the jam touches the bottom of glass without disintegrating into the water, jam is considered to be ready. Next is refractometer method. This is the most common method used by small and large scale fruit processing industries for jam making. The cooking of jam is stopped when the refractive index reading of Abe's refractometer indicates 68.5 degree Brix. The jam should be immediately cooled before putting a drop of it on the refractometer glass, as the reading is calibrated at 20 degrees centigrade. The main advantage of this method is ease of handling. Next is packaging. Jams are packed in the cans or glass jars. Containers including can or jar get sterilized when hot jam not less than 85 degrees centigrade is poured in them. But the lids or caps and the space between top of jam and lid or cap may support the microorganisms, which often lead to microbial growth on the surface, resulting in spoilage of jam. For complete sterilization of the container, following methods are practiced. Number first is hot filling. When cans or jars are filled hot at a temperature of not less than 85 degrees centigrade, there is no need for pasteurization to prevent mold growth. After filling, the cans or jars should be inverted for a couple of minutes to sterilize the lids or caps and then return to upright position. Next is hot water technique. The jars are placed in water bath and boiled for about 5 to 10 minutes depending on the size of container, but it's practicable on home scale only. Next is waxing. The USDA sanctions the use of paraffin wax. The molten wax is put on the jam surface. On cooling the wax, it forms a seal on the surface. Next is use of preservatives. In case of jars with the jam made from fresh, unsulfited fruit pulps, it's advisable to add 40 ppm of sulfur dioxide as KMS. In cans, however, sulfur dioxide may corrode the internal surface of the cans, so should be avoided. Sodium benzoate may be substituted for sulfur dioxide for jams filled in cans. Now, modern processing techniques. Microwave oven cooking is the latest method for processing of jams and jellies for homemakers. An oversized container must be used for this purpose to avoid boiling over. Fruit, sugar and some butter are mixed and allowed to stand for 30 minutes. The mixture is microwaved until it boils with frequent stirring, with further cooking for about 10 minutes more. Jams produced from this mixture keep well in refrigerator for several months or can be canned. Next is freezer jam. The no-cook freezer jams are far by the easiest of these processing techniques. The fruit is mixed with an appropriate amount of sugar, lemon juice if any, is added to the pectin and then it's stirred into the fruit sugar mix. The mixture is placed in sterilized containers and covered with 2-piece metal lids and kept at a room temperature for about 24 hours before placing in the freezer. Next is mixed fruit jam. According to 1994 USDA standard, following combination of fruit ingredients have been recommended for mixed fruit jam. Number first is a combination of 2, 3, 4 or 5 of such fruits in which the weight of each is not less than 1/5 of the weight of combination, except the weight of pineapple may not be less than 1/10 of the weight of combination. Number second is blends of mango, pineapple, orange, apricots, papaya, guava, etc. pulps as available in different proportions to meet the consumer acceptance. Now, sugar, equal in weight to that of blended pulp taken. Next is citric acid. Citric acid to the extent of about 0.75 to 1% by weight of blended pulp. Next is pectin. Pectin to the extent of 0.5 to 1% by weight of blended pulp depending upon the fruits to be used. Next is essence. Blend of appropriate essence to be added to the desired extent. Next is color. A blend of predominantly red food colors may be added to the extent desired. Now coming to the typical recipes. Some typical recipes found useful in large-scale manufacture of jams mentioned by Girdari Lal et al. In 1986 are given as below. To prepare the jam, the requirement of pulp, either fresh or canned, is 75 kg with sugar 75 kg, citric acid 35 g, pectin 150 grade of 565 g and pineapple essence of about 75 ml. To prepare orange jam, 50 kg of live peeled segments required 50 kg of sugar, citric acid of about 250 g, pectin 150 grade of 375 grams and sweet orange essence of about 50 ml. Jams from cherry, mulberry, strawberry, muskmelon, jackfruit, cashew apples, etc. also can be made in the usual way. It may, however, be necessary to vary slightly the fruit sugar ratio and the percentage of acid added. Now, controlled manufacture. Analytical control in the manufacture of jams as well as of jellies is highly important to ensure standards of quality. The various methods of control are as follows. Number first is soluble solids. Determination of soluble solids is of great importance in the chemical control of jam manufacture. Soluble solids can be determined easily with a refractometer or by means of a specific gravity hydrometer or even by a thermometer, as the boiling point of the product depends upon soluble solids in the product. Number second is refractometer method. Percentage of soluble solids can be determined easily with an AB or Zeiss type refractometer or with the pocket refractometer while the boiling is in process. Number third is specific gravity method. The specific gravity of solution is determined at 20 degrees centigrade using a specific gravity hydrometer. Number fourth is total soluble solids. The refractometer and specific gravity methods are useful for the determination of soluble solid contents of fruit pulps which is required to work out recipes. Number fifth is sulfur dioxide. Estimation of sulfur dioxide is highly important when the jam has been made from the pulp that is preserved with sulfur dioxide. According to the Fruit Product Order of 1955, the residual sulfur dioxide in the jam should not exceed 40 ppm. Number 6 includes acidity. 10 grams of the sample are dissolved in water and the solution brought to a boil and titrated with standard N/10 sodium hydroxide solution using phenolphthalein as an indicator. Next is regulating pH of the material. The pH of the material has great influence on the inversion of sugar and the set of jam. The pH necessary to produce a good firm set in pectin jelly is about 3.30, but in jams it varies with the kind of fruit to be used. Next is estimation of pectin. Pectin does not have a definite composition because pectin from different sources behaves differently. Even if pectin is determined quantitatively employing elaborate analytical methods, that alone will not be sufficient to guarantee or predict the set of the jam. This was all about today's topic. Hope you understood well. Thank you.